Alright, ladies and gentlemen, in this presentation we're going to be talking about units of measure. When performing science, we always use Standards International, or SI, as a unit of measure. There's a number of reasons for this. First off, the SI is mostly what you associate with the metric system. There's a couple of differences which we'll go over, but it's mostly what you think of when you think metric. The reason we like to use it is because everything is a multiplier or a divisor of 10. And it's a lot easier to multiply something by 10 or divide something by 10 when going from unit to unit than try to remember a random number. This makes the math a lot easier, and it also makes remembering this a lot easier. The other thing about SI is it allows international communication of science much simpler. If everybody's using the same units, everybody's using the same system, it's much easier for a scientist in the United States to communicate with a scientist in India, or in Russia, or in Canada, or in Belgium, wherever you would like them to be. So a couple things about Standards International. First off, each measure has a basic unit that applies to them. For instance, length, the unit we use is meter. Volume, the unit we use is liter. Mass, the unit we use is gram. And temperature, the unit we use is Kelvin. I know you were expecting Celsius there, but Kelvin is very related to Celsius. It's a simple conversion. And the last thing is time. You probably don't often think of time as a unit of measure, but it is, and the SI unit for that is second. So these are all the base units that we use when performing science. And when you want to provide someone more detail about their measurement, you don't need to come up with a new unit name. You just need to add what we refer to as a prefix. So these are the prefixes. Now you notice on this chart I have written the base units in the middle. So we have second, gram, liter, meter. And all you have to do to, communicate to someone that you're using a larger or smaller version of one of those is use a prefix. For instance, if I want to tell someone that I have 1,000 seconds, I could say, oh, it's a kilosecond. If I want to tell someone that I have 1,000 grams, I could say, oh, it's a kilogram. Whereas if I want to get smaller and say, for instance, tell someone that I have less than a liter, I could use milliliters because each milliliter is 0.001 liters. If I wanted to tell someone that I had less than a meter, maybe I use millimeter or centimeter, measurements that you are familiar with, because a centimeter is 0.01 meters. So there's 100 centimeters in 1 meter. Where a millimeter is 0.001 meters. So there's 1,000 millimeters in 1 meter. And by using these prefixes, we could communicate, I'm using meter, I'm using length, but it's really small, so I'm using millimeter. Or I'm using meter, so it's length, but it's really far, so I'm using kilometer. Now, the reality is, what you really need to remember are kilo, centi, and milli. Those are going to be the key prefixes. So if you can remember those key prefixes and your base units, you will actually be able to handle the metric system. Because you can pretty much do any conversion, any calculation, as long as you can remember that. So your key idea is kilo means 1,000, centi means 1.01 or 1/100th, and milli means 0.001 or 1/1000th. Okay? Now, the thing is, when you're doing conversions with these, because it's prefixes and base units, and the prefixes all have this, always mean the same thing, it's actually a simple process once you get the hang of it. So for instance, let's say I offer you this question. 1 meter is how many kilometers? Now you may be tempted to turn around and say, oh, it's 1,000. But it's not. Because I said 1 meter is how many kilometers. Not how many meters are in 1 kilometer. So whenever you have a question like this, or any question, you always want to start with what do you know? Start right here with what do you know? Then you say, what do you want? What do I want? And what I know is that I have 1 meter, And what I want is that I have 1 kilometer. That's always how you start these problems. Now, when you have these problems, you need to think not just about the numbers. I know in class that we were talking about how when you are using numbers, they should never be naked, is the word that was used. But what that means is that all numbers must be labeled. Oh, I have 6. 6 what? Degrees Celsius? Centimeters? Milliliters? Kilometers? What do I have 6 of? And that's what the label is. See, numbers are descriptive, all right? And remember, numbers are quantitative data, which is the data that we prefer. And since they're descriptive, we need these labels to help describe what's going on. 6 by itself is meaningless, but 6 centimeters, that's been described, so now I know what that means. And these labels are simply these: kiloliter, hectogram, decasecond, decimeter, centimeter, milliliter. Those are the labels that I'm talking about. And you can see that here: centimeter, meter, millimeter. So anytime you write down a number that is a measurement in chemistry, you should always be labeling that number. Now, when you're thinking about this, like I said before, you always start with what you know and you end with what you want. And so just like our labels from before, we need to think about, well, what does this mean? So what do I know? So let's go back to the problem that we had before. All right, what I know is that I have 1 meter. So what I know is 1 meter, and meter is my label. And what I want is 1 kilometer, or not 1. What I want is how many kilometers. Kilometer is my label. Now, because we can't just take away labels and put them back at our whim, we have to have a way to get rid of our labels. So you can see here, I have my 1 meter with its label, and I have my how many kilometers with no label. So what I do down here is I turn this into a math expression. So I take my 1 meter, and I put it over 1, because calculating with fractions is really much easier than decimals. And then I'm going to multiply, because this line right here, when I'm trying to convert from one thing to another, it clues me in that I should be multiplying. So 1 meter times some number of kilometers I don't know, divided by 1. Now, this is the problem. See over here how I have 1 kilometer over 1,000? And see how I've labeled the kilometer as the only label not canceled, so we write it? See over here how we put what I want? You always need to set these problems up so that you end with what you want. So here I have kilometer as what I want. Since I need to get rid of meter, I have to put meter at the bottom here and at the top here. Because, see this note right here? Labels can be canceled like numbers. Just like you would divide numbers in, like, 2 divided by 2 is 1 and 1, so I can ignore it. Or 5 divided by 5 is 1 and 1, so I can ignore it. You can divide labels. So things like meter and meter cancel. And when they cancel, the only thing left is kilometers. And so then I write my numbers. 1 times something I don't know is 1. 1 times 1,000 is 1,000. So see here, I multiply the numbers. And then 1 divided by 1,000 equals 0.001. And since kilometers is the only label I have left, kilometers is what goes there. All right, ladies and gentlemen, we will talk about this more when we work with our measurements.